modulation. You must have read in your theory classes that modulation is a technique in which we are going to change the properties of carrier wave with respect to the characteristics of our message wave, or you can say message signal. So in this case, as far as amplitude modulation is concerned, we need two signals, right? The message signal, that is going to be an audio signal here. So we are going to take an audio signal as a message signal, as well as we are having a high frequency signal called as carrier signal. You must have read about the benefits why we are using the high frequency signal as a carrier signal. There are so many benefits because we want to do the modulation, and there are so many benefits of modulation. So we can communicate or transmit our information to a far place, as well as the practicality or realizability of antenna and height of the antenna, as well as the noise performance, other things you must have read in your theory classes. So here we are going to deal with two types of our amplitude modulation. One is the double sideband modulation with carrier, and the other is double sideband modulation with suppressed carrier. It means that in one case we are having carrier signal also. When we are modulating the signal, the modulated wave that we are going to transmit uh, is also containing the carrier signal also, right? And in the other case, we are suppressing the carrier so that we can reduce the other benefits that we are going to have, such as power, transmitting power, and other things that we are willing to reduce. Okay. So in this case, we will see how we are balancing the carrier. So in this case, when we are having this modulated wave as a DSB with carrier, so we have a modulator, balance modulator block in which we are using to balance the carrier, and you are going to see the balanced output, or you can say that the DSB or amplitude modulated wave without carrier, or you can say the suppressed carrier one also. So in this experiment, we are going to see our audio signal, the message signal, how our message signal is looking like. So we will plot and see on the DS so that how our message signal, how much frequency and amplitude we are taking as a message signal and audio signal. As I already mentioned to all of you that we are considering audio signal. So in the kit, we need to have oscillators so that we can generate the message signal as well as the carrier signal. Okay, as I told all of you that in a real case or real scenario, we are having all this information and data that we want to communicate or transmit to a further place. But when we are performing all these experiment on a prototype kit, our main purpose is to illustrate the process and the concept how these things are happening. So in order to illustrate this thing, we need to generate a message signal. We need to have some message signal, as well as we need to have a carrier signal. So you will see, I'll share the link. You will watch the video, then you will understand that on our kit we are having oscillator blocks for message signal as well as the carrier signal. So we are picking those two signals and giving it to a modulator block where the modulation is going to happen. So we will see how our message signal is looking like, how our carrier signal is looking like. We will plot both of them on the DSO, and you can easily notice that a carrier signal is having higher frequency. It means that the waves are closely spaced as compared to the message signal. So you can directly read on the DSO that how much frequency we are taking as a carrier signal, and both the signals are sinusoidal signals. So we are taking the sinusoidal signals as a message signal, the low frequency signal, and the high frequency sinusoidal signal as a carrier signal. After modulation, you can see the amplitude of the carrier signal we are going to change. We are not changing the frequency of the carrier signal, but as per amplitude of the message signal, the as I told all of you that we have chosen or we have taken the audio signal. So where the amplitude of the audio signal is maximum, we are going to have modulation, or the amplitude of the carrier signal as a maximum. So there would be modulation, as well as you must have read about various modulation like under modulation, over modulation, or ideal modulation, where modulation index is 1. So you can easily see on the waveforms I have changed, I have turned the knob to the right, and I have illustrated when we are having under modulation where modulation index is lesser than 1. I've also illustrated when modulation is 1, and also when modulation index is greater than 1, or you can say that modulation percentage of modulation is greater than 100%, right? So you can easily see what the changes we are going to notice on the waveform, the modulated waveform, when we are changing the modulation index. Okay, so all these things we are going to see, as well as we are having a demodulator block also, where we are going to receive the signal. So I have illustrated two methods. One is the wired medium, where I have used the wire communication because both kits are at the same place. So we have leveraged to do that also. So we have used the wired medium also to illustrate the signal or the data, the modulated wave is getting transmitted and received at the demodulator block, and accordingly demodulation is going to happen. And we'll see there are various techniques of demodulation, envelope detection, and other techniques in case of our amplitude demodulation. So you can easily see how we are modulating, as well as we have used another method of antenna. We have transmitted the modulated wave using a transmitting antenna and received that wave using a receiving antenna that is attached to the demodulator block. So in real scenario, these two things are happening at a far place. We are transmitting the signal from one place and we are receiving the signal at a far place. As you must have listened or watched the AM radio at your homes. In in a decade ago, we used to listen to cricket updates and other news updates using those AM radios. There were some stations. Now FM radios are more common, and we generally use all these things. You must read about all these differences between AM and FM. What are the advantages of FM over AM? Because in case of AM, the range is more. You can transmit or broadcast to the larger area, but in case of FM, you are having lesser or defined geographical area in a city or around a 5 to 10 kilometer range. We are going to receive FM signal, right? So all these differences you are going to see. But in case of AM, we usually transmit audio signals and we receive at the receiver using antenna. You must have seen the antenna in your radio that we used to flip it up and keep it, or the length of the antenna, we used to extend it and accordingly receive the signal, right? And tune to the particular station, AM station, and listen to the news or any other information that the broadcasting station is going to broadcast. So you can easily understand, and the illustration is like we have used that antenna also to transmit as well as to receive the signal. So all these processes we have performed in this experiment, modulation as well as demodulation. The things that you need to notice is what is our message signal, how it is looking like, what is our carrier signal, and how it is looking like, and how much amplitude and frequency that we are taking here for illustration purpose. After modulation, all the three cases, the under modulation, the ideal case of modulation, that is modulation index is 1, as well as the over modulation. What are the changes that we are going to see if we are changing the frequency of our carrier signal? I have illustrated that also. What if we are changing the amplitude of our message signal? Then how modulation index is going to change. All these things have been illustrated in this experiment. So you can easily watch and understand all these concepts, as well as the demodulation part is also done. So we are having two links that I'm going to share to all of you. I would advise all of you to save these two links and share to those students who have not present here, so that they can also watch that particular video. So I'm going to share the links for modulation and demodulation in the chat box. Okay. So I've shared one of the link, the modulation one. I'm also sharing the demodulation one. So you need to click on the link and watch the video. If you are having any query regarding the video, while watching the video, you can pause the video and ask whatever you want to ask, or whatever query you are having. Okay. So I have shared second link also. See, these two links comprise of your first experiment, experiment number 1, whose objective is to study and plot the waveforms of double-sided